Okay, so welcome back. So now the second part of this video picks up from where we left off. Now, before we get to this slide, I do want to do an example. If you're following your notes, you see off to the right there, it says example 9, page 10. So I'm going to scoot over to the textbook. So the textbook is here now. It might be a little small. I'm going to go to page 10. So this is your e-text. So if you go into the Pearson site, once you have it all established, you have access to the digital textbook. So e-text, and then you can just let it load, and then you can type in the page number you want to go to. So if I type that in, it's going to take me to the page. So problem 10. So question says, determine whether the sampling method appears to be sound or is flawed. So clinical trials. Researchers at Yale University conduct a wide variety of clinical trials by using subjects who volunteer after reading advertisements soliciting paid volunteers. So, do you see any problems with that? And hopefully you're screaming at the screen saying, of course, it's voluntary. It says it right in there. And that's exactly the problem. It's voluntary. So, is it random? That's another way to phrase it. Is it a random way that they got their subjects? And it's not random, because they did a few things. They looked at, they created advertisements that only select people were going to see, because not everybody has access to those advertisements. And they're paid. So what more bias could you get? I'm going to get paid. Darn right, I'm going to join that survey, that study. I'll be a subject. So again, it was voluntary, but there's all kinds of other flaws in that whole process. Advertisements that not everybody was going to read, and it was Yale University, so a lot of people probably don't get the Yale Chronicle, whatever the newspaper is. So there's the problems with that example. Okay, let's switch back. So now we kind of have a sense of what's good and what's bad. So let's look at some more of those steps. So we got analyze, and I'm just going to we'll put it all on the page. So after completing our preparation by considering the context, source, and sampling method, we begin to analyze the data. Graph and explore. An analysis should begin with the appropriate graphs and explorations of the data. Apply statistical methods. A good statistical analysis does not require strong computational skills. So you don't have to be a math wizard to be good at stats. Calculators do a lot of the work for you, but you got to be organized. That would be the one thing I would say about stats, is you got to be organized. You can't be all over the place. You got to be methodical in how you think. A good statistical analysis does require using common sense and paying careful attention to sound statistical methods. So again, we're going to get into more of those methods as we go. Conclude. The final step in our statistical process involves conclusions, and we should develop an ability to distinguish between statistical significance and practical significance. So what's the difference? Well, statistical significance is achieved in a study if the likelihood of an event occurring by chance is 5% or less. So they give you a couple of examples. Now again, a lot of this is common sense thinking. Even though they're trying to throw percentages at you, don't worry too much about them. Think logically. So it says getting 98 girls and 100 random births is statistically significant because such an extreme outcome is not likely to result from random chance. So again, if you wanted to look at that 5%, 98% or 98 is within 5% of 100. So that's why they're saying it's statistically significant. So that's that 5% look, just in case you're curious. But just thinking common sense wise, if you get 98 out of 100 girls in 100 births, that's pretty remarkable. The chances of that is really small. It's definitely less than 5% chance that that's going to happen. So that's statistically significant. Whereas the next one, getting 52 girls in 100 births, is not statistically significant because that event could easily occur with random chance. So yeah, we would expect around 50 girls out of 100 births. So 52 is not too far off. So that's not a big deal, statistically speaking. So that's kind of the idea with statistical significance. So is there a really small chance that it's going to happen randomly? And if the answer is yes, then it's statistically significant. Okay, so now practical significance. Whoop, let me go back. Oh shoot. There we go, sorry. So practical significance, it is possible that some treatment or finding is effective, but common sense might suggest that the treatment or finding does not make enough of a difference to justify its use or to be practical. So we're going to see a couple of examples, more examples of this in a second. So let's jump into them. ProCare Industries once supplied a product named Gender Choice that supposedly increased the chance of a couple having a baby with the gender that they desired. In the absence of any evidence of its effectiveness, the product was banned by the Food and Drug Administration as a gross deception of the consumer. Suppose that the product was tested with 10,000 couples who wanted to have baby girls, and the results consist of 5,200 baby girls born in the 10,000 births. This result is statistically significant because the likelihood of it happening due to chance is only 0.003%. So chance doesn't seem like a feasible explanation. Now you're probably saying, well, wait a minute, that doesn't seem quite right for the percentage. You know, if I said 5,200 out of 10,000, that's not 0.003%. But they're looking at it a little differently. They're looking at the chance of getting exactly 5,200 baby girls in 10,000 births. If what you're thinking is 5,200 or more, so if I get 5,200 or more, all of those chances together would be about 40, 50%, 48%, somewhere in there. But getting precisely 5,200 out of 10,000 is what they're looking at, and that's why it's such a small percentage chance that it happens. So technically, it is statistically significant. That 52% rate of girls is statistically significant, but it lacks practical significance because 52% is only slightly above 50%. Couples would not want to spend the time and money to increase the likelihood of a girl from 50 to 52%. No, in reality, the likelihood of a baby girl being born is about 48.8%, not 50%. So technically, it is a slightly better chance for boys to happen than it is for girls. But for statistical purposes, we say 50-50. Okay. So, what are some problems with all of this? We talked a little bit about voluntary responses being a problem, but what about the other end of it? What about the analyzing side of it? What problems can we have there? So misleading conclusions. When forming a conclusion based on statistical analysis, we should make statements that are clear even to those who have no understanding of statistics and its terminology. Sample data reported instead of measured. When collecting data from people, it's better to take measurements yourself instead of asking subjects to report results. Oh, how much do you weigh? I'm not going to measure it, but I just want you to tell me how much you weigh. Are you going to tell me the truth? Probably not. So, or how tall are you? Well, it's better to have the person that's doing the study do the measurements. So be careful with that. Loaded questions. If survey questions or results are not worded carefully, the results of a study can be misleading. So, just saying, for example, if you were looking at traffic pollution or pollution, in general, and you had the choice of saying, well, is traffic a bigger contributor or manufacturing? Just by putting one in front of the other in the question, it might tend to have the effect that people would choose the first choice versus the second one. And then flip-flopping it, it would be the same thing. You pick the first choice and not the second one. So that's kind of what they're talking about with loaded questions. You're steering them to answer a specific way. That happens in the news a lot, unfortunately. So the order of questions. So you can kind of lay them in a specific order, so that way you're trying to steer them to a specific result that you want to happen, and that's not cool. That's not cool with stats. Non-response occurs when someone really refuses to respond. So again, if somebody doesn't respond, then that's you're not getting the true idea of what the results actually are because they just didn't respond. Percentages. Now, percentages are always a big thing that people have issues with. So we're going to actually see an example, if I'm correct. So in your lecture notes, it says example 31 on page 12. So we're going to flip back to the textbook for a second, and then we're going to try to get all this to work out. So let's see what happens here. Okay, so we're back to the textbook. And so now if we go to page 12, let's see what 31 says. Now I'm going to see if I can make this a little bit bigger because it's, there we go. That's better. So let's scroll down here. So marriage proposals in a survey conducted by the knot.com, 1,165 engaged or married women were asked about the importance of a bended knee when making a marriage proposal. Among the 1,165 respondents, 48% said that the bended knee was essential. Listen up, guys. Okay, so what, and girls, what is the exact value that is 48% of 1,165 survey respondents? Well, does anybody know? Well, let's go to a blank slate. So now, so this is number 31. And so again, what is 48% of 1165? Let me just make sure I wrote it right. Yeah, exact value. Value of that is 40% of this survey respondents. Now, if you're not sure mathematically how to do it, it's actually very, very quick because all you're going to do is multiply. If you multiply, that will give us that result. Now, before you multiply, you have to do something with that percentage. Does anybody remember? Hopefully you're screaming at me, make it a decimal, because that's what you got to do. So if we want to make it a decimal, remember the decimal point has to move to the left 2 places. So we're going to write 0.48. I'm going to make this a little bit bigger too. There, so 0.48, and let's see, times 1165. And so, what do we get when we get that? Well, I'm going to have to pull up a calculator because I don't want to do that in my head. So 0.48 times 1165, 559.2. All right, let me back in there. 559.2. Boom. All right, so that was the answer. Now, if we want to be a little bit technical, it didn't say if we wanted to put units on the answer or not, but if you wanted to put on units, you could. So you could say respondents or survey respondents. Units are pretty important in most cases, so you want to try to get into the habit of always putting units on your answers. Sometimes that could be a little bit of a stickler when it comes to that. So, all right, so that is your first question. So the next one says, could the result from part A be the actual number of survey subjects who said that a bended knee is essential? Why or why not? And so, could that be the actual number of respondents? Hopefully you're saying no. We can't have a decimal, right? How could you have a part of a person? Well, that's another course, so we're not going to talk about it. So no, because the answer is a decimal. Needs to be a whole number for a person. All right. So what about C? What is the actual number of survey respondents saying that a bended knee is essential? So now, again, you have a choice. Say, okay, well, I'm going to have to round. Which way do I round? In this case, I would actually take either answer. So some of you might say, well, 559.2, that's closer to 559. So I'm going to round it down. So some of you might say 559 survey respondents. But I would say, or some of you say, I will round that part of a person up to a whole person, just because I'm feeling generous. So, whoops, survey respondents. So I would take either one personally. Part D, among the 1,165 respondents, 93 said that the bended knee is corny and outdated. What percentage of respondents said that the bended knee is corny and outdated? So now we're going the other direction. So we know how to get rid of a percent. We got to change it to a decimal, and then we can multiply it. So if we're going to do the opposite, what do you think we're going to need to do? Instead of move the decimal point and multiply, we're going to do the opposite. So we're going to divide and move the decimal point the other way. So that's what we're going to have to do next. So let me move my math, whoops. Let me move my math window down here. So we want 93 over 1165. So if we divide that on our calculator, 93 divided by 1165, we got 0.0798. And a few decimals after that. Okay, so now we're done. No, we're not done. I didn't move my decimal point. So 7.98%. And I would probably take 8% on that as well. Or 8%. So that is that. So, yay! All right. So that, my friends, is everything for section 1. So hopefully that wasn't too terrible. We're going to have, and I'm going to try to make the videos a little bit shorter, not so much narrative in there. But again, this first chapter is going to have a lot of terminology, so I really got to try to explain it. So once we get into the next later chapters, we're going to see a lot more math. And it's going to be a different presentation style as well. PowerPoint is not going to be the basis of this course, so don't freak out about that. I hate PowerPoint. All right, we'll see you in the next video.